follow the same procedure of adding or subtracting the SP altogether. You have been given a program which is f equal g plus h minus I plus j, and you have already been given an information about x10, x11, x12, 13. Try to see which registers are required to be spelled into memory. Okay, so you have already been given a reference sheet. Look into the reference sheet. What are x10, x11, what is x20, x5 and x6. Let me discuss the first part of the solution. So initially x5, x6 and x20 are not a part of function interface. So we know that x10, 11, 12 and 13 are the registers used for communicating with the function. Okay, so how do we spell the contents of x5, x6 and x20? Again, by decreasing the SP. Why we are decreasing it here? Because we are pushing the contents. So whenever you need to perform the push operation, you need to subtract the stack pointer address by -4. We are spelling 3 different registers, so that's why we have reduced the value of SP by -12. Okay, and then we push the value of x5, x6 and x20. Okay, so after doing this, you can begin writing your program, actual program, implementing your program. And since we have done that a couple of times before, so I'm just going to show you the arithmetic that is being performed. x10, x11 are supposed to be added together. Similarly, x12, x13 corresponding to I and j are supposed to be added together again. And then we need to subtract the results of x6 from x5. So this is how we can write a sub-instruction x20, x5 and x6. So x20 corresponds to f, okay, so which is holding the results of this expression. And we need to return f. How do you return a value f? How we return the output from a machine, from a function. Again, look at the reference sheet. x10 to x17 are the registers which are used for arguments or returning the results. Okay, so if it is only one value that we are supposed to be returning, so where we will be placing it? Which register? Yes, x10. So we have to write a line of instruction which loads the value of x20 into x10. Okay, so this is the interface. This is the same bowl where we are supposed to be putting our output. Okay, so x10 is now contains the value of the function output. What do we need to know next? Yes.
I have a question.
Yeah.
But why would you need to spell the contents of the temporary register?
This is what I'm going to discuss in the next slide. Okay. Yeah. So what are we going to do next? Our function is complete. The implementation is completed. So we have to retrieve or restore everything what we did before implementing the function. What we did, we spilled the contents into memory. We have to restore them back into the registers. Okay. So how do we restore the contents? We have to pop the contents from the memory. Now after looking at this implementation or this execution, you have a clear idea that a stack or any other data structure is just a concept. Okay, when you pop out, we always have been talking about the pop. Once the element is popped out, it is removed from the stack or it is removed from the memory. It does not remove from the memory, it is still there, but the stack pointer is now pointing to another location. The top of the stack is now pointing to another location. So the data is still there, but it is no more a part of this stack. Okay, so you have loaded the value of x20, x6 and x5 back into the same location and updated the stack pointer by 12. Again, always it's a rule of thumb, whenever you are performing push operation, you have to reduce stack pointer by -4 if you're pushing one element. If you're popping out one element from the stack, so you have to increment the stack pointer by 4. And once the function is finished, how do we return to the next instruction? For example, if this function leaf under example is being called, we have to jump back to the next instruction with the help of JALR instruction. Okay, so what it will do, it will jump to x1, whatever the address stored in x1, it will jump to that instruction and continue executing from that point onwards. Okay. All right, so I'm moving forward. So old values of register x5, x6, and x20 were spilled into memory and restored. Sometimes values are never used, and thus they must be categorized as temporary. Okay, sometimes we just perform intermediate calculation, and those intermediate calculations are stored in a temporary register. This is a convention, this is a standard developed by the RISC-V developers. Okay, so once we know that these are the temporary values, we have some temporary registers from x5 to x7 and x28 to x31. So whatever value is stored in temporary register, we do not need to spill them into memory. Okay. So temporary register content does not need to be spilled into memory because we do not need to restore them. So according to this idea, we did not need to spill the x5 and x6 content, and we could end up avoiding executing 2SW and 2LW instructions. Okay, so in your exam and your assignment, you need to determine yourself whether the values that you are using, the register that you are using, whether it's a saved register or temporary register. In the previous example, we used x5 and x6 as a temporary register. So we did not need to spill those contents into memory because they are already temporary registers. All what we need to preserve safe registers. Okay.